In this lesson, we'll talk about the basic descriptive statistics that are necessary to excel on the quantitative reasoning section of the GMAT Focus Edition. So there aren't that many, and you're not going to require like a college level statistics understanding. But you do need to know what an average is, or arithmetic mean. And the way that you solve for an average, of course, is to take the sum of the terms and divide by the number of terms. A weighted average is when there's an inconsistent variance or difference in the terms. So something like 7, 38, 55, 87, 932. That's a weighted average because it's not equitably distributed. An unweighted average, however, is when there's a constant difference between each and every term, like 1, 2, 3, 4, 5, or 5, 10, 15, 20, 25. And the average of any terms that are equidistant from each other in an unweighted average is the average of the set. So we know that if we were to sum 5, 10, we'd get 15. 15 plus 15 would give us 30. 30 plus 20 would give us 50. 50 plus 25 would give us 75. And 75 divided by the 5 terms would give us 15. But similarly, I could take the 5 and the 25, which are equidistant from 15, add them together, divide by 2, and find that 30 is divided by 2 is 15 as well. And this also works for any set of consecutive integers or consecutive multiples. So like consecutive odds have a constant difference between two, consecutive evens have a constant difference of 2, consecutive multiples of 5, such as these, have a constant difference of 5. So you just have to make sure that there's a constant difference throughout the set or sequence to be able to use these types of, I don't want to say tricks, but techniques and tactics. Now, median is the other way of finding a middle point statistically. And it's the central term when the values are placed in numerical order. And it's the single central term if the number of terms is odd, but it is the average of the two central terms if the number of terms is even. And the path to finding a median on this exam is to first count the number of terms. Sometimes it'll just be given to you and determine whether it's even or odd. Then just count up to that term, the single term if it's odd, or the middle two terms if it's even, and find the median that way rather than doing the old cancel out, cancel out, cancel out, cancel out, because you don't need to do that. And by canceling out in such a fashion, you'll often end up making a mistake. If you just count to the median from the bottom, you'll be able to make sure you don't make any errors. And we actually know that the average is equal to the median for any unweighted set or sequence. So for instance, our 5, 10, 15, 20, 25, well, the average was 15, and so too is the median. And so the path to solving for some of the harder, like consecutive sums or trickier combinations of a sequence is often to recognize that it's an unweighted sequence or an unweighted set, and you have a median that you could probably find a little bit more quickly than summing all of the terms and then dividing by the number of terms. But you know that that median is equal to the average. And you can also apply that idea of any two terms. So you could take the highest and the lowest, divide them by 2, and get the average as well. So there are a lot of unique little tactics and techniques that you can use with average and median if you know all of the pieces that are outlined on this slide. But we also have a handy dandy tool to find averages, particularly known as the average circle. And you can see that it's set up so that it's 3 parts. Up top is the sum of the terms. On the bottom left is the number of terms, and on the bottom right is the average. And you can see the operations between the pieces of the circle visually represent what's happening with an average. So how do we use the circle? Well, it's the visual representation of average is equal to the sum of the terms divided by the number of terms. And any two values can solve for the third. And you could use multiple circles to coordinate complex averages. And you can add or subtract raw sums or terms, but not averages across multiple average circles. So it's just a really handy way when the test gives you more steps to process to keep track of the pieces in a less algebraic form and instead a more visual form that you could probably use a little bit more directly. And you can see sum of the terms divided by the number of terms, that's the average. Sum of the terms divided by the average can actually solve for the number of terms. And the number of terms times the average can give you the sum of the terms using the average circle. So a couple other basic statistics. Range is just your greatest term minus the least term. Mode is going to be your most frequently occurring term or terms. You can't actually have multiple modes. It's highly unlikely, but it's the most frequently occurring term. And then we have standard deviation. And standard deviation is exceedingly limited in what is tested on the GMAT focus. It should never be a requirement to fully calculate standard deviation. Finding the differences, squaring the differences, taking the average, all of those steps are completely excessive and could take more than the 3-minute maximum we have for any of these problems in the quantitative reasoning section. So you're not going to need to do that. You just have to have a broad conceptual understanding about what that standard deviation calculation is going to require. And that's the average and the distance between each and every term. And you have to understand proportionally what happens with standard deviation. So if your differences in the terms increase, your deviation increases. If your differences in the terms decrease, your deviation decreases. If you have no difference in any of your terms, your deviation is going to be zero itself, because that's how nothing is represented mathematically. So if you've got a set of 5, 5, 5, 5, 5, 5, and 5, your standard deviation is zero because there's no difference between any of those fives. And if you have no change in your differences in the terms, your standard deviation will also remain constant. And the only other piece that can come up with standard deviation is what is known as the normal distribution curve. And to be honest, in some instances, they'll even give you this curve if it is relevant to a question on the exam. So let's just talk about the distributions. You can see that the mean is the center of the bell curve. And you'll recognize this as a bell curve from things such as the distribution of the scores on the GMAT focus. It's a constant percentage distribution for standard deviation. And you can see that there is 68% of the distribution between one deviation of the mean on either side of that mean. So 34 plus 34. There's a 27% distribution between one and two deviations of the mean, positive and negative. And there is 5% more than two deviations from the mean, above the mean, and below the mean. This is just the distribution. And what happens is that there's a constant difference in between the values. So if this was like a scaled score, if we said that the average score was an 80 and two deviations above the mean was a 96, that means that there's a constant difference of 8 between each of the distributions, the standard deviations on the curve. So like from 0 to 1, 34% would get an 80 to 88 on that scoring curve. Again, just kind of the definition of normal distribution. So let's go ahead and move over to the whiteboard to take a look at how standard deviation and the other descriptive statistics can be tested on the GMAT focus exam. So here we have a sample problem solving question. We'll set up the scratch work, as always, listing A through E. We've got real numbers, so we might as well write those out. We've got 65, 73, 82, 92, and 111.5. And we'll skip to the end, figure out what we're being asked for. And we're being asked, what is the lowest Perla can score out of 100 on one of the final two tests and still maintain an average of 90 for all 5 tests? So we're going to write a little shorthand. Lowest P can score and still average 90. So we'll know that we'll have to take a little bit of notes here to track that in full, but there are some tactical clues already in this problem. We're being asked what is the lowest that she could score. So it's got a logical estimation and evaluation opportunity, or at least a clue there, because you're like, yeah, that's not asking for exactly one thing. It's asking for like the extreme of a range. And we've got numbers in the choices, which indicates that there's possibly a back solving opportunity. So we got to start taking notes. So far this quarter, Perla has taken 3 of 5 course exams, scoring 90, 92, and 95 on a 100-point scale for each. Okay, so total so far And I know I need the total, so I don't need to write them out individually. It's 90 plus 92 plus 95. So let's just do 90 times 3, which is going to be 270, plus the leftover 7, and we've got 277 so far. So now, this is when we could start using our little average circle. So I'm going to cheat a little bit and draw out some perfect circles just because I'm really bad at drawing a circle freehand. But we know that we can set up a couple of average circles, and we'll start with the very first one. So we know that we've got that 3 terms, and we've got a 277, and we know that, I actually don't really need the average, I suppose, for the very first one, but that would end up being what we'd have 92 and a third, but it's not really important. So this is just our first 3. Then putting in our next circle, we want to average 90 for all 5 tests. So all 5, we want a 90 average, and we've got to have 5 tests. So our all 5 total, we can find out pretty directly by just doing 90 times 5, or 450. So we know that the final 2 total is going to be the difference between those two things. So 450 minus 277. So again, just kind of working through our structure, 450 minus 200 is going to be equal to 250, minus 70 is going to get me down to 180, minus 7 is going to be equal to 173. So we know that we're trying to figure out the lowest that she could score on one of the tests. So we actually want to consider what's the maximum for the other of the tests. So we know that test 4 plus test 5 has to be equal to 173. But if we max test 4, we've got to go look for what the max is. And it says the lowest she could score out of 100. So that means that the maximum is going to be 100. So the max for test 4 is 100. And we're trying to solve for the lowest that she could score at this point. I probably could eliminate choice E because that's over 100. That didn't make sense to begin with. And it's certainly not 92 either, because that wouldn't even be the lowest of the 3 options that were available. So if you got stuck somewhere before here, at least look at the logical evaluation of it. Can't be D or E, really, because they would be not even the lowest of the 3 grades that were given, or lower than the 90 that we're being asked to average. But if the max of test 4 is 100, then the minimum for test 5 would be 73, and our correct answer is choice B. So you can see the average circle, really handy way to figure out what I need in terms of all 5, and then it's a little bit of logical evaluation. In order to find a minimum of one thing, you often need to maximize the other. So let's scroll on down and we'll take a look at one more example here about statistics. So setting up our scratch work once more, we've got A, B, C, D, E, put a little line over top, and we are being asked for the number of students 95 plus on MT for midterm. We got 10, 20, 40, 80, and 200. So we start at the beginning. We know that the total is equal to 400. And we know the average is equal to 85. And then we get the key phrase of standard deviation. And you're going to have to bear with me as I try to draw a vaguely straight line and a standard deviation curve. I'm going to try for a third time. Well, we'll go for it. There we go. All right, good enough. So now we'll draw a straight line down the middle, pretending that peak isn't a little bit to the right, but it's going to be fine. That's my average. And we know that the score here was an 85. So now we could build in our little normal distribution curve around said average. So this is -1 standard deviation. This is +1 standard deviation. And this is going to be minus 2 standard deviations, and plus 2 standard deviations. So we know the standard deviation of the class midterm scores is 5. So that means there's a difference of 5 between each of the deviations. So that means there's an 80 here, there's a 75 here, there's a 90 here, and a 95 here. And if we recall back to our percentages, there's going to be 34% here. We're going to have 34% here. We're going to have our 13.5% here and a 2.5% here. And so now we've just got to take our 400 and find 0.25 of that. The easiest way is going to know that 1% is going to be equal to 4, 2% is going to be equal to 8, and so therefore 2.5% is going to be equal to 10. And there's our answer just by basically mapping the information to the standard deviation curve. We can determine that the correct answer has to be choice A. And again, you can see on the GMAT focus, you are never going to need to fully calculate standard deviation. It's just a matter of knowing the curve and applying the basic concepts. And that's basically the main thing with standard deviation and all of the descriptive statistics that you'll encounter on the GMAT focus. So go ahead and attempt some practice problems on your own, applying these relatively rudimentary statistical concepts to improve your performance on the test.